Okay, ladies and gentlemen, this is how you do line of best fit worksheet. These are the these are the problems. I'm going to show you how to do number 1 and number 2. But what you're trying to do here is create a line of fit. It says task number 1, find the equation for the line of best fit for each of these scatter plots. Write a sentence describing the relationship between the two variables on each scatter plot. So I'm going to go in and I'm going to type up here, I'm going to write my name, date, and period. All right, the first step in this is to look at the scatter plot and kind of understand what the scatter plot is saying. What do we have going up the y-axis? The y-axis is this axis. The x-axis is the horizontal axis. Type those in using a text box. Whoops. All right, so we have number of burgers on the x-axis, and we have number of people on the y-axis. So first thing is to draw a line of fit that has two characteristics. One, it's parallel with the data, and two, it's generally right in the middle, so roughly speaking you have the same number above as you have below when you draw the line. So I'm going to go ahead and select shapes. I'm going to click somewhere around here, try to draw a line that is parallel. So these two, this is an outlier, so it's going to bring down the data. I have to take that into account, so it'll bring down the data a little bit. So if I can draw a line that maybe goes right here, there's my line of fit. Okay, so that's pretty good. I have some numbers, some things below and some things above, some things that are actually on the line. These, when I'm creating the equation, from here, my first step is to write the coordinates of 2 points that actually lie on the line. So I'm going to go up here and I'm going to look at this, and I got an easy point right here. Anytime you see a point that crosses right at the intersection, right at the crosshairs of 4 squares, like this one would do right here, or you could say this one right here, I'll go ahead and mark that as a point, and I'll mark this as a point. And the reason I mark that as a point, because if I look at this, I can see 0, 0, right? If I can see 0, 0, that's my origin. All right, and that's where I start my count from. So that's going to make it pretty easy for me to label these 2 points right here and work with these 2 points to find the equation. So my point right here is 0 going, it always goes x first and then y, but 0 going left and right, 0 in the x direction, and 10 in the y direction. So anytime my y-intercept is always where x equals 0. Y-intercept is where x equals 0. All right, so, and my y-intercept is in slope-intercept form, y equals mx plus b. B is my y-intercept. B is what we call my y-intercept. And m is what we call our slope, our rise over run. Okay? So we have this point right here, and we have to pick out another point. So this point up here is going to be the point 5, 50. Okay? All right, so I'm going to go ahead to find my, I first have to, once I have 2 points, I can go ahead and find the slope. And once I find the slope, I already know what b is, because b is going to be 10. Because it says y-intercept is where the x equals 0, where x equals 0. So x equals 0 right here, so that's my y-intercept. 10 is going to be my y-intercept. So I don't have to worry with putting this into point-slope form. I can put this into slope-intercept form right away. All right, so now the only thing I need to do is find my slope. So I'm going to create a chart right here. Okay, and you don't have to create a chart, but it's a good way of organizing the numbers. So 0, 10 goes here, and then 5, 50 goes right here. Right? So the change from 0 to 5 is 5. On the x side, the change from 10 to 50 is 40. Okay? So my slope, m, is going to be, we call it rise over run, right? Well, rise is represented by the y variables, or y coordinates, and run is represented by the x coordinates. So I get 40 over 5, so m is going to equal 8. 40 divided by 5 is 8. So now all I have to do is I have to go up here to the top and plug it in. So I say y equals mx plus b. Well, let's go ahead and replace m with 8. Okay, I'm replacing m with 8. And let's go ahead and replace b with 10. Okay, so if I look at this, it says find the equation for the line of best fit. That's the equation for the line, so that part of it is done. All right. Now what I have to do, it says this next task right here, it says to write a sentence describing the relationship between the two variables on each scatter plot. All right, so the relationship between the two variables on each scatter plot is your slope. So I'm just going to go ahead and open up a text box. And when I write this, basically what I'm saying here is that my x variables are number of burgers. Okay? So x variables are number of burgers. So as the number of burgers rise by 1, increase by 1, the number of people increase by 8. Right? So as the number of burgers as x increases by 1, so think about it, if I plug in 1 here, then the y, the number of people, the y-axis, the y-coordinate, is going to increase by 8. So if I plug in 1, I'm going to get 8 in terms of the y. Now we'd also have to add our starting point to it, which is 10. But if I plugged in 2, then it's going to increase by, it's going to be 16, right? So every time I plug in 1, I'm increasing it by 8. All right? And so that's basically your setup for this whole entire thing. You could take this right here and copy it and paste it for all 11 of these things, and then this right here, you understand, this number of burgers, that's your x variable. Okay? Number of people, that's your y variable. Okay? And the 8 is your slope. Okay? So that's basically how you would do it. You know, you look at this and you just replace that whole thing and just take out the number of burgers and put in whatever the x variable is, and then take out the slope and the y variable and replace those for every one of them. So you could go ahead and copy that down and copy it 11 times for all 11 of these problems. Just paste it in there. Remember to understand that, hey, an increasing slope goes up from left to right. So I said increase here by 8 because that slope goes up from left to right. Okay? All right, so those are my two answers. I've circled my two answers. Right? Now, I'm going to show you one here where I cannot see the y, the origin, 0, 0. Okay, so here's 10 and here's 20. I can't see the origin. Okay, I don't know where the origin is. So when I create the equation, I'm going to have to use point slope form. So my first task to do is to go ahead and create that line of best fit, right? So that line of best fit, remember, has to go through the center. Okay, and it can be a little bit subjective, but it has to go through the center, and it has to be parallel with the data. Okay, so that's pretty good. These points right here are kind of bringing up the line a little bit, right? So there's a line of fit, and then I'm going to go in and pick out 2 points. Okay. So now for the most part, I'm going to guess where these 2 points are, right? So if I move vertically straight up from here and I put a point right here, that's going to be my x value is going to be 45. Well, what's my y value going to be? If I move over here, I move it over, that's probably about 45. Okay? Right? So 45 comma 45. Okay? So that's 1 point. Now I can look at this one right here. Maybe I can go 25 right here. So I can go 25, which would be right about here on the line. These points have to be on the line, okay? So 25, and if I move over, we could say that that's 20, right? We'll say it's 20. So this point right here is going to be 25, comma, 20, right? So now I have my 2 points. All right, so I'm going to go ahead and set this up to, I'm going to put it into a table. There's my first point, 25, comma, 20. And then my second point is 45, 45. I'm going to take the change in the y over the change in the x. So m equals, to go from 20 to 45, that's 25. To go from 25 to 45, that's 20. Okay, so it's going to be the vertical change, or the rise. The rise is 25, because y is vertical and x is horizontal, over the run. Run is horizontal. Okay, and the run change is going to be 20. So if I can reduce this, I want to go ahead and do that. So I know that 5 will go into both of them. 5 will go into this 5 times. Okay, and 5 will go into this 4 times. So my slope right here is 5/4. Okay? So now what I'm going to use here is point slope form. Okay, we did a lot of work with point slope form, and there are a couple different versions, 3 different versions basically of point slope form. We would have, y equals, I like to use this one, y equals m times the quantity x minus x1 plus y1. Okay? From here, I can create the equation of the line by just plugging in what I know. I already found the slope, and I already know I can just use this as my, this right here, this will be x1, and this would be y1. Okay? So I'll just go ahead and write them down. So x1 equals 25, and y1 equals 20. Okay? So if my slope is 4/5, then I'm going to go ahead and plug in all the stuff that I know. Right? So I'll write it up here. So y equals, instead of m, I'm going to put 4/5. Okay, then I write parentheses x minus x1, which is 25, right? X minus x1. x1 is 25. And I'm going to say plus my y1, which is 20. Okay? So this would be good. Okay? If it asks for up here, it says find the equation for the line of best fit for the scatter plot. So if it doesn't say specifically put it into slope-intercept form, then I'm good to go. This is in point-slope form. Now, the only problem with not converting this to slope-intercept form is I don't know where the y-intercept would be. Okay, I'm not quite sure where the y-intercept would be. So if I want to figure that out, it's a couple quick steps. What I have to do is distribute. If I have something that's in parentheses, I'm going to use the distributive property and multiply 4/5 times the x, and then I'm going to multiply the 4/5 times the 25. Okay? So I'm going to write it as 1.25 because I know that 4/5, or not 4/5, but 5/4, sorry, 5/4. I know that 5/4 is 1.25. It's 1 and 1/4. Okay? So that's going to be 1.25. So I'm going to say 1.25x minus, and I can go into my calculator, and I'm going to say 1.25 times my 25 right here. Okay, so that's minus 31.25, and then I have to say plus 20. Okay, so that and that, those are like terms. I don't want to just leave it like that. I want to simplify it, right? So I'm going to say y equals 1.25 x, and when I subtract that, it's going to be minus, so my y-intercept on this one is going to be a negative, minus 11.25. Right? Okay. So that's slope-intercept form. I'm going to go up here, and I'm going to go ahead and actually take this right here, and I'm going to copy it, and I'm going to go down here, and I'm going to create a text box. And really paste that into the text box, Control V. So as the number of burgers, now this one's not number of burgers, so I'm going to take out number of burgers and put the x variable, which is highway miles per gallon. So as the highway miles per gallon increases by 1, okay, the city, so this I'm going to take out the y, right? This is going to be the y variable. The city miles per gallon increases by 1.25. Okay, so 5/4 is 1.25. All right, and that's answering task. That's answering task 2. Okay, so I circle them. There's task 1, or this one. Either one is fine. Either equation is fine. There's task 1, there's task 2, it's answered, the line of fit is drawn, 2 points are drawn, okay, and those are the things that I'm looking for, this type of work on there. That's it. So have at it with the rest of them and complete them just like that.